Before we start this very exciting video, a large thank you to Dylan Turnbull for supporting me on Patreon. You're awesome, man. Also, shout out to Steven Schmidt for upping your pledge. You guys are kick-ass. I hope you enjoy the video. Hello guys, in this video we are going to create a lock-on system. This will be part 1 of 2 parts in this video series. I know you guys have been requesting this for quite a while, so let's just jump right into it. Okay, so first I'm going to go over here to my player, and we have a script called Player Manager. We're going to need to make a script called Character Manager, which will be the base class for our Player Manager and our Enemy Manager, which is a future script that will hold our enemy behaviors. So let's just call this Character Manager. Don't worry, we're not really working too much on this today, actually not at all. I'm just going to open up this script here, and I'm going to erase the start and update functions, as well as put my namespace in, as is tradition. And I'm just going to make a public transform on this script, and I'm just going to call it lock-on transform. But before I do that, I'm going to come over here to the Player Manager, and I'm going to make that inherit from the Character Manager. Excellent. Perfect. I'll go back over here, and I will say public transform lock-on transform. And this is just going to be a transform we place on our character that will allow somebody else to lock onto you via this transform. So let's go to our character, and we're going to right click, create an empty object. I'm going to get a bit closer here so we can see what we're looking at exactly. Going to drag this up to about chest level, maybe a little bit higher. Yeah, that looks great. Going to name that lock on transform to match the name of our variable so it's not confusing when we're looking for it in the game. Going to actually go to our enemy now and do the exact same thing. I'm just going to paste this game object. Probably going to have to recenter. Yes, I am. Let's just reset the transform up here. Move it up to about chest level. That looks wonderful. Okay. So next, we're going to need to figure out a way to lock on to our enemy via script. So that's where the Character Manager comes in. So what we're going to do first is drag in our lock on transform variable on our player. And on our enemy, we're going to make a script called Enemy Manager, which is like our Player Manager, but for enemies. Don't know why I had 2 enemy stats. Just going to erase one of those. Must do that in accident. So as I was saying, we're going to make a script called Enemy Manager. This will work for our enemy like our Player Manager works for our player, except this will handle AI stuff like looking for a target, attacking a target, etc., etc. But for now, we're just going to keep it completely blank. We're just going to make sure it derives from the Character Manager. And for that to happen, I need to put in my namespace, which is SG, as is per tradition. Going to erase the update and start functionality here, and I'm going to make sure that it says Character Manager. And now when we save that, our enemy will have a public variable for a transform called lock-on transform. And yep, there it is. So let's drag in the lock-on transform we just created. And now we have something we can lock onto on our enemy. But we need a way to read that variable. And what we're going to do essentially is angle our camera to rotate towards that transform. So in our camera handler, let's create a function to look for potential lock-on targets in the area. In this video, we'll only be finding the nearest one, but the next video we'll have multiple, and you'll be able to shift through targets from left to right, just like in Souls. But for now, I'm going to hand myself public void handle lock on float shortest distance or shortest distance from target. We're going to call it, and we're going to say equals mathf dot infinity. So this is going to be used to measure the distance between targets and pick the shortest one that is closest to us. Collider. We're going to say colliders. So this is an array of colliders. We're going to say physics dot overlap sphere, and we're going to put that on the target transformed opposition, which is our player, and we're going to make the radius 26. So this is going to make an invisible sphere that searches around the player, 26 units in diameter. And then we're going to say for a for loop here. We're going to say colliders.length. Then we're going to say Character Manager, the variable, Character Manager. We're going to say colliders I dot get component Character Manager. So it's going to search all the colliders that you detected with the overlap sphere for a Character Manager script. And then we're going to say if character does not equal null, which means if the Character Manager variable, or if there has been a Character Manager found in your targets, we're going to do some logic here. So open up these curly bracers. And first, we are going to say vector3 lock target direction equals character dot transform dot position minus transform. Oops, sorry, it's supposed to be target transform dot position. And then we are going to say float distance from target is equal to vector3 dot distance between our target transform dot position minus our character dot transform dot position. Okay, and we're going to say float viewable angle. This is going to be vector3 dot angle between our character lock target direction, and our camera transform dot forward. Now, this is basically going to be for detecting a viewable angle. So if a target is off screen, we don't want to be able to lock onto them. That's all this is going to be used for. You want to lock onto stuff that's only on your screen. So we're going to say if character dot transform dot root does not equal target transform dot root. So basically, this is so we can't lock onto ourself. It can't equal the root of our transform, so we won't be able to lock onto our own player self. And then we're going to say and viewable angle is greater than, say, minus 50, and viewable angle is less than, say, 50. You can change the angle if you want, but that should do it for me. And distance from target is less than maximum lock-on distance. This is a variable we're going to have to create now because we don't want to be able to lock on to things that are too far away. You want to be able to lock on to something that's within a reasonable fighting distance, otherwise you'll be locking onto things across the map. So I'm just going to say maximum lock-on distance here, and we're going to go up here and create this as a public float so we can edit that. And yeah, it's getting kind of across the screen there now, so I'm just going to actually hit enter here so you guys can see what's going on. Looks a bit easier to read for you all. There you go. So up here, I'm just going to make a float here for a maximum lock-on distance. So let's just put it right here. Public float, maximum lock-on distance, and I'll initialize that at 30. Yeah, 30 is good. I did all the testing in my other project, and this worked out fine. Why is this giving me an error? Oh, that's supposed to be a comma, not a subtraction sign, I believe. So there we go. Yes, perfect. Wonderful. Okay, let us continue onward. Get my notes here. Available targets dot add character, and now we have to make a list called available targets because we're going to have more than one target when we're searching for these. If you have multiple enemies, you will have multiple potential targets. So let's go up here, and next to our lock-on details, we're going to make a list for character managers, and we're going to say available targets. We're going to say equals new list character manager, and this will house all the potential things we are able to lock onto within our range. So perfect, but we're not done yet. We're actually about halfway done right now. So we're going to say under here, under this for loop, we're going to make another for loop, and now we're going to use this. Make sure you change the I to a K, or any kind of other character that's not I, because we've used I before. Whoops. There we go. Now we're going to say available targets.length. So we're going to search through these available targets, or .count rather, sorry. And we're going to say float distance from target vector3 equals vector3.distance. Same as before. Target transform position, and we're going to say available targets. I spelled available wrong, didn't I? I did. Available targets k dot transform dot position. Goodness. Okay, I have to change that because that is bothering me. Transform dot position. I'm going to rename this variable in just a second. Let's see here. There we go. Good. All right, now we have to check for the target that is closest to us. We're going to say, if distance from target is less than the shortest distance, then what we're going to do is we're going to say shortest distance is equal to distance from target. So now we won't find another target unless it's closer to us than what we currently have. And then we're going to say nearest lock-on target equals available targets K. I'm going to say dot lock-on transform, which is the variable we had in character manager. Now, we need to create the variable for nearest lock-on target. So let's do that right now. So just up here near our lock-on settings here, I'm going to make some headers for these in the next video too to make it a little more organized. We'll do a cleanup video also at the end of the next video. So we're going to say public transform nearest lock-on target. Gotta store that. Let's save that. Okay, and that does it for now in handle lock-on. So now we need to do the rotations. When we're not locked on, obviously we can rotate the camera freely, but all a lock-on system is forcing the camera to rotate. But first, let's actually make our lock-on inputs. So we need a lock-on flag to know when we're actually locked on. So we're going to say public bool lock-on flag. This will tell us when we are actively locked on to a target. We also need an input to tell when we press the button to lock on. So public bool lock-on input. This will tell us when we're hitting the button to look for a lock-on target. Okay, and I'm going to breeze through this next bit because you guys have made so many inputs with me now and you guys know how it works. So let's go to the player controls. I'm just going to go to actions. I'm going to make something called lock-on. So let's duplicate A. I like A. A1. Cool. Lock on. Drag it up here. Not lock on 1. Lock on. What? Why is... Oh, I apparently already made a lock-on button. I did not know that. Okay, delete. I must have done that when I was testing stuff. So, yeah, F for the keyboard or right stick on the gamepad. That looks great. Cool. Let's go back into the script. I am so silly. Open up the input handler, and we're going to go down here, and we're going to say private void handle lock-on input, as is the naming convention states with everything else above it. So as we learned in the last video, we actually don't call our delegate here, we call it on enable. So let's do that too, not make the same mistake as before and make our garbage collection bad. Input actions dot player actions dot lock on dot performed plus equals I equals greater than a lock on input equals true. Wonderful. Everything is simple when you know the syntax. Okay, let's go back down here now. Yeah, that looks fine. Minimize that and make our screen less cluttered. Now in here, we're going to do a couple things. Let's first start off by saying if lock on input and lock on flag is not true. So exclamation mark lock on flag. Actually, you know what? I'm going to say equals false because I just like it better. It's very clear. I won't accidentally look past it. I know that it's false. It's very obvious to see. So inside these curly bracers, let's do some logic. We're going to say lock on flag equals true. And we're going to say above that, lock on input equals false. So once you click the lock on input, it's going to come in here and reset it. Wonderful. Now let's say camera manager dot handle lock on. We need to call our camera manager. I think it's camera handler. I'm getting my projects confused now. Yes, it is camera handler. I remember now. So let's, whoops, almost did it again. Camera handler. And I'm just going to, there we go. Copy that. And on awake, we're going to say camera handler equals find object of type camera handler. There we go. Wonderful. Good to go. Okay, now where are we going next? Let's check on this. Okay, so now if we're doing this, we need to also we're going to say else if down here. We're going to say else if lock on inputs and lock on flag is true. So let's do that real quick, because if it's true, we want to disable lock on. So if you hit your lock on input and you're not locked on, you want to lock on. If you hit your lock on input and you are locked on, you want to lock off, obviously. So open up some curly bracers. Again, we're going to say lock on input equals false. And then we're going to say lock on flag equals false. Wonderful. There we go. Lock on flag equals false. And we want a way to clear our targets too. So I'm just gonna say -- clear lock on targets. It's very simple. We'll do that in a second. That just involves us resetting all of our lock on transforms to null. So let's save that, go to our camera handler, and let's actually minimize this first. We got to call it on the tick input before we forget. Otherwise, it'll never be used. Handle lock on input. Wonderful. I love modular looking code. Okay, let's go to the camera handler again, and now on our rotations. So this is the logic we employ if we're not locked on just in our standalone game right now. So let's say if, and then we're going to say input manager, input handler, sorry, and looks like we got to call that on the script because we don't have that called. So let's do that right now. Now we're going to put that to, I guess these are all camera variables, so right on top would be the best place. Yes, let's do that. Let's stick it right up here. We're going to say input handler, wonderful, space there, make it look nice. On the awake, we'll call that, we'll say input handler equals find object of type, as we did in the input handler script, and then we'll say input handler. Alternatively, you could say equals target transform dot get component input handler, but yeah, that works too. We're just going to do it that way. We're going to say if input handler dot lock on flag equals false. We should really also say, and we don't have a current lock on target, but we don't have that variable yet, so we'll come to that in a second. Yeah, we'll come to that in a second. I won't throw too much at you right now. So if we're not locked on, we're going to do this logic. So let's copy that. And let's paste it in here. Now, else we are locked on. So let's employ some lock on logic. So it's going to be very similar. So I'm going to breeze through this because we have covered camera rotations. If you are confused, please comment below and I will try to explain the best I can. But we're going to say float velocity. And this isn't important in this video, but let's just put that there for now because we're going to use it in the next video. So ignore that for now. We're going to say vector3 direction, or dir, whatever you prefer, equals current lock on target dot position minus transform dot position. So let's make a variable for our current lock on target. So we already have a way to detect the nearest target, but when we have the nearest target found, we want to make it our active target. Because our active target will be different depending on, because you could be locked onto the target that's further away to the left of you, because in the next video, we're going to have multiple target selection. So public transform current lock on target. This is the thing you are currently and actively locked onto. And now we can say, and current lock on target equals null. So back down here, we're going to say vector3 direction equals current lock on target dot position minus transform dot position. Very straightforward. I assume you guys know what this means. So let's say direction dot normalize. Then we're going to say direction dot y is equal to 0. Don't want any y. And we're going to say quaternion target's rotation equals quaternion dot look rotation direction. So we're going to rotate in the direction that was created above. And then we're going to say transform dot rotation is equal to target rotation. Next, we will say direction is equal to current lock on target dot position minus camera pivot transform dot position. Then direction dot normalize again, and target rotation. Whoops, not rotation. Target rotation is equal to quaternion dot look rotation direction, and vector3 Euler angles equals target rotation dot Euler angles. Then Euler angle dot y is equal to 0. Again, no y. And then we're going to say camera pivot transform dot local Euler angles is equal to Euler angle. So basically, we're forcing our camera to rotate towards the direction of the target that we are locked onto. Simple. Let's save. Now, let's jump back to the input handler because I just thought of something we forgot. Down here on the handle lock and input, this is all well and good, but we're going to need to actually create an if statement here. So first, let's say camera handler dot current lock on target is equal to camera handler dot nearest lock on target. Right when you click lock on, you lock on the thing that's the closest to you by default. So let's save that. Now let's make a public void clear lock on targets. So let's just say available targets dot clear, which just clears the list, straightforward. And then we'll say nearest lock on target and current lock on target equal null. This is just for safety. There we go, wonderful. Actually gonna put that above there just for naming's sake. I know I'm picky. All right, let's save that. Back to the input handler. Okay, so we actually don't need to say camera handler dot clear lock on targets here, but I'm going to just because I want to try something off camera, but you don't need to put it there if you don't want to. You just need it on the else if statement. So, right, the if statement. Before I forget, we need to do that too, because we need to actually take this, copy it. Now we're going to say if camera handler dot nearest lock on target does not equal null. So if we even have a potential target at all, then we want to say camera handler dot current lock on target equals nearest lock on target. Otherwise, we'll get an error. And we only want lock on flag to be true if that is true and we have a target. So let's erase that from there. Otherwise, we get an error. Okay, that actually looks fantastic. I think that is everything. So let's save that. Yeah, and let's jump into the game. Okay, we're here in the game. So I'm going to run around. If I press the lock on key, boom, we lock onto a target. That is so cool. If I press it again, we will lock off the target. And I can press it again, we will lock onto the target. So now, guys, we have a functioning lock-on system that will detect the target that is nearest to you and lock onto it, which is pretty freaking exciting. And in the next video, we're going to make it so we can't lock onto something that is behind a wall, so it will detect any kind of structure or environment. And we're going to make it so we can switch to targets from left to right across the screen. We will also be resetting the camera to center after we've blocked on, and much more. This was a system I worked a long time on in my solo project and made purely from scratch with very little help. Me and a friend of mine, Sharp, actually shot back and forth a few ideas on this. Very pleased with it. I'm glad I could finally share it with you guys, and the end product will be so fantastic. Again, if you enjoy this video, please leave a like. It really does help my series get around, guys, and I always appreciate it. And if you're feeling super generous, check out my Patreon below. I will see you guys in the next one where we will complete our lock-on system. You're wonderful. Take care. Talk soon.